Ja, wir sind wieder live von der Grazer Bühne und freuen uns über den ersten Vortrag mit einem leicht weinenden Auge, weil Karsten Wolf hat uns leider nicht persönlich besuchen können von der Universität Bremen. Karsten, wir kennen uns schon sehr lange rund um das Thema Videos, Tutorials und so weiter und so fort. Und ich bin jetzt ganz, ganz gespannt, was du mit AI machst. Und ich hoffe, der Ton funktioniert gut. Wir bitten dich um deinen Vortrag.
Okay, yes, so let's switch to English and welcome. And I'm sorry not being in Graz, but I got a bad cold. So today's talk, it's not just Lisanne and me, but it's like a bigger team. There's also Fatima and Jan, and Fatima is a data scientist, and Jan is a research software engineer. So it's part of a bigger project together with some other universities in Germany. But the thing I'm showing here is really a part done at the University of Bremen. So we are in a University Future conference. So what is the goal? I think we all want to create rich learning environments which support deep learning instead of shallow learning of our students. And so in this talk, I want to talk about what is the problem, and then I want to show what we are doing about it. First on a general idea, and then go more into the specific implementations, and maybe we can talk about learnings and next steps in the discussion. So we started and we wanted to use, or we are already using ePortfolios. So ePortfolios are kind of multimodal media collections from students where we can document and reflect on the learning processes, and the teachers can support them in becoming better. So what we know is that feedback is most important for creating these deep learning processes of students. And so if you give feedback to them, it motivates the student to actively engage in the learning. And also there's this concept of highly informative feedback. So this not only gives you information how you have done something, but also if your strategies are good and where you should go next. So there are some limitations, because if these feedbacks are late, or they are shallow, or they're even totally missing, this really decreases the autonomous motivation of the students. They put some effort in their portfolios, and when you don't give good feedback or too late, then they're demotivated. So what are the opportunities and challenges we try to address in this project? We want to help teachers to give feedback, but the biggest problem in giving feedback is that the teachers, they don't have enough time resources, right? So because if you want to give, you have, just imagine I have a portfolio group with 200 students, and when I want to give feedback to each of them, it's pretty hopeless. And so we looked at AI if it could help us. So these are some examples of real portfolios of my students. These are like media biographies, and you can see a lot of, well, some text, but also some memes and some charts and all that. And this is another portfolio where a student, he was assessing explanatory videos and for math, and then he tried to come up with a selection of good explanatory videos and create a kind of a lesson plan and some exercise pages. So you can see this is very multimodal. You have a lot of like text, you have documents, you have pictures and all that. this is called generative learning. So the students have to generate all this stuff, and in this process, they employ deeper learning strategies. So what would be the general idea? Well, you have your task for the students, and then you provide some kind of feedback button, and then let's go to some large language model, and the llama is giving the feedback. So I probably all had this idea in some way or the other. Problem is, does not work. If you just use a large language model and you try to assess these very complex products of students, like GPT-4, it's assessing mostly the generic essay characteristics, but it's not really looking at the nuances of the students' work. And there's more evidence to this, and they compared human graders and AI graders and showed that there's not a lot of correlation between these two. And so we came up with some modular architecture instead of using just one multimodal large language model, especially, and this is what I want to talk about today, to provide better explainability of the scoring and the feedback generation, so that the students better understand why they got this feedback. There are things you can address here, but I will focus on this and also on a combination of different scoring models. So let's look at the architecture. The architecture is quite complex, so don't be afraid. We will go through it step by step. So this is a rubric-based multimodal assessment and feedback framework. And let's look into it. So it starts with a generative learning of the students. They actively engage with the materials and compose their, it could be portfolios, it could be a presentation, it could be some text, picture, chart document. And after this, we are going to extract all the data out of the submission. So it could be a PDF, for example. When you would do something like using a layout parser, it's a library to identify parts of your document, like tables and titles and pictures and all that, to get some more information about the document. So, and this is probably a thing all of you do if you're using rubrics for assessment, is that you're first in box 1, you are doing your didactical planning and which contents, learning goals, which performance should be shown after the course, and you start with your task construction and problem formation. Just collect all the background and supporting materials and create scaffolds. And also you write down your rubrics in some kind of rubrics scale. So now in box 2, you see now you have to be more specific about this. So you try to operationalize all your rubrics. And it could be like, it should be at least more than 300 words, and the target would be 700 words, and so on and so on. So you really go through your whole rubric. And this is the center of our approach, is that now we take each of these rubrics and ask ourselves, okay, which computer-based and AI model could help us to assess this. So there are different model types. So, so there are rule or statistic-based models, like readability formulas, or you could even say it has to be at least 300 words. You don't need a large language model and start your nuclear reactor to look if somebody has written more than 300 words. And when you have these different types of machine learning based models, and again, you can use discriminative models, which have been there for a long time, like computer vision models to see what is on the slide, right? Or like I showed the layout parser to try to understand the structure of a document. And when you have large language models, so we don't only use large language models, but incorporate them in them. And when you have different types of optimization you could do, like prompt engineering, RAGs, fine-tuning, agentic workflows, and verification. So can't go into detail on this, but these are the possibilities. And what we are then creating is a kind of table. In practice, it's a JSON table with all the criteria in the rows. And the columns are the students. And here you can see that we just assign values to the different criteria. And when we use another large language model to create a feedback construction, to create feedback, sorry, and so we give to this large language model, we give a criteria, we give a upload, the submission of the student, and we give to it this table of criteria, the fulfilled criteria or the level of criteria. And when this AI is creating a feedback, which is when given to the teacher who should review it in a way, and this is given back to the students, and then they should have look at it with explanations, and hopefully then they start to revise their submission. To give you a concrete example, this is from a task where we had to create explanatory videos. So you have a video from the student, and then you extract audio and you start to extract to detect the scenes to have like the main shots of the video. And then you ask a multimodal large language model to identify this and to assess it. For example, with Mayer's principle of multimedia design. So this is an example. You have on the left side the prompt. I'm sorry, it's on German because it's like in a German teaching context. And on the top, you see the video of the scene. And when the large language model is creating this description of this can then later can be used for further evaluation. We're using open source models because we host everything in the university. So sometimes we only can use these smaller models, probably more computing power, a little bit better. Okay, also the audio is then transcribed with Whisper, and when this text is given to a model to assess it. And also for audio analysis, using models. These are models to test how fast is somebody speaking, or here you can see as a JSON an outcome of this. So very easy things like how long was it? 2 minutes 39, a feedback. And then also the average speech rate, for example. And there are some Python libraries you can use for that. Okay, and all this then is put together, and you get a final feedback text. So you definitely see the modular approach we are using. And here you can see that the prompt is already addressing the different JSON files which were created in the process to be used in the final feedback. So I want to show you some small study example results, and so this was in just these explanatory videos, and we had this really very specific criteria. I just say it was were too many. When we gave feedback to our tutors for assessment, and the contents of the videos were captured well, but still there were some problems, and you see that's a feedback text, and our tutors, they marked it like green was correct and red is not correct. So you see that there's quite a lot of text which was not really fitting to the videos. From the students, they said that it was too long, it was sometimes redundant, and they liked the feedbacks from the human tutors more because it was more precise or shorter, and also the LLM's feedback lacked sometimes critical depth, and it's something we are working on. And a second example, this is from a lecture from me where students have to do quite different things like creating a concept map, or review an online course of screenshots, or analyze TikTok videos, or create a presentation. So let's look at the task. We had to go to an online course and follow it for 8 hours and to document the screenshots and then to assess it didactically. And so this is the result if you give this into ChatGPT, and you get a zero-shot result, and it's very redundant and it's very generic. So this is definitely not the way to go. Everyone who's thinking that large language models will really replace all tutors and teachers, it's not going to happen this way. Probably not in our as well, but as you see, but so this is a short video where you can see our internal tool. So the student, you can drag and drop the student submission, and so this is for really rapid turnaround to work with scripting and with prompting. As you can see, the system is working and doing the different is doing the different analysis, and then it gives back its feedback. So let's look at this in a little bit more detail, so you can choose the model. As you can see, this is all open source models. And when we split up different aspects like keywords, like minimal, maximal word, so because the goal is that in some years, people should be able to do this by themselves without any technical competencies. And now you have a user feedback. And then you have also for the assessment rubrics another form where you can define all your assessment criteria. And as you can see in this example, sorry, the quality is better, I think, than the general thing. Now we also add some other text quality metrics, and these are not large language model stuff, but these are just discriminative models we used for this. Okay, so what is the feedback from the students? So for this task, I show it's a really small group, so it's not really can do averages. It's just some kind of first look at this. The problem is a little bit that our students are very critical doing working with us on this research because we're very critical on AI in general. And here you can see that the feedback was so understandable and helpful for them from these low numbers, but at least the format made the feedback much more accessible. So at least us doing some user experience research paid out. And this is another task where we just had to create this pro-contra lists on smartphone ban in schools. There's a little tendency that it seems to be easier. So probably the more complex task is, the more difficult it gets to really get to good feedback results. So let me end this talk. What are our next current steps of the rubric framework dev? We definitely need larger student groups. So if you're interested in this research, just reach out to us. And if you have students who are more open to AI research, also, we are doing a new project together with Andreas Breiter here at University Bremen at U-Twente about really explanatory videos. So we will create this thing which is assessing explanatory videos from students in more detail. So I hope I could give you some insight into our projects, and I'm really, really open for questions. Thank you, and I'm sorry again for not being there in person.